Okay, so the next question would be question number 9. They give you 2-point charge Q1, Q2. Diagram is given. The rectangle. Sketch the electric field strength diagram at point O. So question A, they just want you to sketch at point O. So you have two sources of electric field. One comes from Q2, another one from Q1. Q1 is negative because the given values is negative over there. Q2 is positive. So let's say this one is negative, this one is positive. So positive electric field going out, negative electric field going in. So you can see that I just try to draw the one along or towards the point O, but that is the important part. So this one to the left, this one, oops, this is towards that direction. This is from 2, this is from 1. Okay, so I just redraw it over here, point P, 3 point O. Okay, so this is E2 and this is E1. The next question, they want to determine the resultant electric field strength at point O. So if we want to find the E net, you have to find individual electric field first. Okay, so if you guys still remember, the formula for E would be E equals to KQ over R square. We're talking about E1, Q1, R1. So R1, R2 you can use 4 centimeter. R1 you have to find, so you can find the R1 first. So if I draw a triangle, this, so this is point O, this is your Q1. This is 4 centimeter, this is 2 centimeter. So R1 is over here. R1 is equal to square root of 2 square plus 4 square. 4 square. So if you calculate that one, you should get 4.472. Okay, if I were to change the meter, okay, so if you want to substitute inside the equation, you have to use SI unit. So that one is one of the values. And then another important thing is the angle. Because if I were to resolve, so let's see if I want to find E1 X, right, and E1 Y, I need to find this angle over there. So I will find that angle first. Put this one as theta. Okay, so theta is over here. Tangent theta is equals to 2 over 4 at tangent that one, 26.57. 965. Okay, so that's the important values we already have. Already calculate. Okay, next part, maybe you can find the individual E first. So E1 and E2. Use the same formula, Q1 over R1 square. Okay, this is a vector quantity or vector equation. You don't have to substitute the negative values. Tak perlu Q1 is 4 micron. And then R1 we calculate just now, 4.472. Don't forget to take square. And this one will be 1.80 times 10 to the power of 7 Newton per coulomb minus 1. This one is 8 microcoulomb. This would be 4. Okay, this one is to the left. Okay, E2 is to the left. I can write that one. E1, you have to resolve that one. Huh? So because you have E1, which is both in X and Y, so we have to resolve that one. So like always, I just do this one in table. So E1, E2, and this is E at point O. Okay, the easiest one is E2, it is to the left, so you can substitute negative 4.5 for X component. Okay, this one you can straight away write 0. And then E1, so I just go back to the diagram over here. The angle is 26.565. So I just place it over here. So you will have E1x to the right, E1y downwards. So E1x is positive, be positive. E1 is 1.8, and then the angle just now is 26.565 degree. And then this one you have, okay, because this is downward, so you have to put negative. Negative 1.8 times 10 to the power of 7. Then you have to multiply with the sine 26.565. And here you should get, don't forget the negative. Okay, again, you just have to sum for one column and the other column. So y component, that one would be negative 8.05 times 10 to the power of 6. Over here, you should get negative 2.89 times 10 to the power of 7. Okay, so you have two negative x and y. If I were to redraw, so it means to the left and downwards. So EOX, E naught Y. So your resultant vector will be in that direction. The angle that you want to put is toward the x-axis. Just copy this one. Paste it over here. So my E naught is equals to square of E naught x plus square of E naught y, then square root. Okay, I ignore the negative because this one will be positive because you take the square. This one you should get 3 times 10 to the power of 7 Newton per coulomb. Okay, and then the direction, you have to do y over x. Again, ignore the negative sign for this one because you just want to find the magnitude of theta. This one you should get 15.57. Okay, because the location is over here, so it is below negative x-axis. Okay, so next question is question number 12. Okay, you are given a diagram. They have two charges, Q1 and Q2, and they want you to find electric potential at point A and B. So electric potential is V lah. So question want to find VA and VB. And then they want to find delta VAB. Then the last one they want you to find change in potential energy when the charge move from B to A. So they basically want you to find delta U. But you know delta U is equals to work. So because you want to find from B to A. Okay, and question A. If you want to calculate phi, you can use the formula KQ over R. Okay, remember that this is a scalar quantity, so it doesn't have any direction. You just have to substitute all the negatives value inside the charge. So Q1 and Q2, kalau ada negative, you substitute negative. Then you just have to add everything up. Okay, example over here, let's see if I want to find V at A first. So at point A, basically you can ignore everything. Ignore point B first lah. So you have a positive charge over there. This is the point A and this is the negative charge. Q1 is equals to 2.4 nanocoulomb. Q2 is equals to negative 6.5. So I just can write negative as well. The distance is 0.05. So that one would be your R. Okay. So it will be KQ over R 1 plus KQ over R 2 2. Okay. K is the same. I can factorize that one. R in this case is the same, so 0.05. Left with Q1, which is 2.4 times 10 negative 9 plus negative 6.5 times 10 power negative 9. This one should get negative 738 volt. So the unit will be volt. Okay, just leave it like that. Okay, VB, again you do the same thing. KQ1 over R1 plus KQ2 over R2. Okay, now the only difference is the R lah, because you have that kind of position here. You just redraw it over here. So positive, negative, Q1, Q2. This is your point B. A little bit towards Q2. 0.06, 0.08. So this is 0.08. Okay, so basically the same thing. VB equals to 9 times 10 to the power of 9. Q1 is equals to 0.08. Don't forget to put negative. Divided by 0.06. And for this one, you should get, okay, for question C, sorry, for question B, they want to determine the potential difference between point A and point B. And for question C, actually, they want to find if the charge from B to A. So just now, I think I do this one wrongly. I have to correct this one. So basically, from B to A, so A minus B. Okay. So this one also I have to do BA as well. So delta VBA, just change this one. So it will be VA minus VB. Okay, don't forget to put the negative. So negative is positive. So delta VBA that I got here is negative 33 volt. Okay, and then the last question, they want to find delta U, but delta U is equals to volt. Okay, BA, be careful with this one. So this one is actually Q0 VA minus VB. Okay, again, subscript is not really important. So I mean in terms of this one and this one, but the most important thing is this one. Which one minus which one, that's the most important part. Final minus initial. So Q0 is 4.5 nano,